Okay, guys, now we're going to talk about acceleration. This is another term that's probably familiar to most of you. To accelerate is to, usually in everyday life, we mean that to mean speed up. It can also mean to slow down. That's another way that we can think about acceleration. And sometimes when we mean slow down, we say the word decelerate. But in physics, it's all the same thing. It's all acceleration. And acceleration is defined as the rate at which the velocity changes. So here again, we see this word rate, which makes us think to divide by time. And what's changing over that time? Well, it's the velocity that's changing. So I'm going to write acceleration A equals the change in the velocity, delta V, over the time t. And that's our mathematical definition. In fact, I'm going to say is defined as, so that looks like an equal sign with an extra dash. That's is defined as. So this is the definition. We can note right away that this is only going to work if my t, my change in time here, is not 0. In other words, this has to be an average acceleration. We aren't going to be able to deal with instantaneous acceleration. A word on units. The units here, well, what do we have? Velocity in standard units, that's meters per second. And then time is seconds. So we're going to have this very unusual unit, which is, this very unusual unit, which is meters per second per second. Meters per second, right? This is velocity here, and this is time here. Now that's sort of a clunky unit. Usually we write this meters per second squared. So that's the unit that we'll use, meters per second squared. Let's make sure we understand it. In breaking down that unit, might help us understand what acceleration is all about. So what does it mean if I said, for instance, that an object had an acceleration of 10 meters per second squared? Well, what that means is every second the velocity changes by 10 meters per second. So if it starts at 0, after 1 second it will be going 10 meters per second. After 2 seconds it will be going 20 meters per second. After 3.5 seconds it'll be going 35 meters per second. That's how that unit works. Give you some understanding of how acceleration works. We noted before that velocity is a vector, so acceleration is also a vector, which again seems to imply that it can be positive or negative. And that's important, that it can be positive or negative. And you might have thought to yourself right away, well, positive acceleration must mean speeding up, and negative acceleration must be slowing down. If you were tempted to think that way, you're wrong. That would be a very naive way of looking at it. It's unfortunately a little bit more complicated. What we can say for sure, let's take a look. I'll write the definition up here again. Acceleration is change in velocity. And I'm going to write change in velocity as v final minus v initial. Remember, change in is always final minus initial over t. Well, given that definition, what does positive acceleration mean? Well, that means that my numerator has to be a positive number. How does that happen? Well, v final must be bigger than v initial. So if v final is bigger than v initial, then the velocity must be increasing. So positive acceleration means increasing velocity. That's non-negotiable. That comes directly out of this definition. V final is bigger than v initial. That's the only way I get a positive number in the numerator. If v final is smaller than v initial, I get a negative value. In which case, by the way, then I'd have a negative acceleration. So what does negative acceleration mean? Well, v final is smaller than v initial. In other words, the velocity is decreasing. This is v final is smaller than v initial, so I get a negative number. So that's pretty easy. Positive acceleration, increasing velocity, negative acceleration, decreasing velocity. And now you're probably saying to yourself, well, doesn't that also mean if the velocity is increasing, isn't the speed increasing? Well, it turns out not necessarily. And to understand why that's the case, I'd like to actually look at another type of graph called a velocity time graph. Last module we looked at position time graphs. This is a velocity time graph. So velocity time graph on the vertical axis. Now, try to make that a little bit better. The vertical axis, we're going to have velocity on the vertical axis. This is v in meters per second. And the horizontal axis will be our time axis, time in seconds. And maybe I have, let's draw something. Maybe we've got an object, and let's say it starts up here. It starts with some positive velocity. And maybe we plot its velocity over time, and we get a chart or a plot that looks like this. I'd like to think a little bit. We have a few different segments here. Let's divide it up. Let's say that this, from here to here, let's call that segment A. From here to here, we'll call that segment B. And then back up to here, we'll call that C. And then finally segment D. So we've got these different segments again. Well, first of all, let's think about what's happening to the velocity. Okay, well, let's look at A. The velocity is going from positive values to 0. So the velocity is decreasing. So if I might actually clear some space so I can write this down. Clear a little bit of space here. So let's just, this is my time axis again. So what's happening in A? Well, in A, the velocity is decreasing. Right, it's going from positive values to 0, which means that the acceleration must be negative, negative acceleration. Okay? We already know that. That makes sense. What about the speed? Well, what's happening? Well, it's going from some positive velocity, let's call that, give it a number, we could say that this is like plus 3 meters per second, down to 0. So it's also slowing down. So I'll say slowing down. So now let's take a look at B and see what we get for B. Well, what's happening to the velocity here? Well, the velocity is going from 0 to negative values. Well, negative values are even smaller than 0, right? Negative 1 is a smaller number than 0. So the velocity is still decreasing, which means it's still a negative acceleration. But now let's think about the speed. What's happened? Well, the speed here is 0. It's not moving. And what's the speed down here? Well, let's call maybe this is a velocity of negative 3. The thing that's different about speed than velocity is speed is never negative. You don't have negative speeds. So right here, the object's moving. It's moving at 3 meters per second, which means it's moving faster than it was up here where it wasn't moving at all. In other words, the object has sped up. And that's surprising, because here we have this weird situation where the velocity is decreasing, but the speed is increasing at the same time, which is unusual, and it has everything to do with the fact that, or maybe I should say it's surprising, and I think it has everything to do with the fact that speed can't be negative, but velocity can. The velocity is decreasing because it's going from 0 to negative values. Since speed is never negative, the speed is going from 0 to some non-zero value, so it has increased. Okay, let's take a look at C. Well, C, what's going on? It's going from, the velocity is going from negative 3 to 0. Well, it's getting bigger. 0 is bigger than negative 3, so it's increasing velocity, which by definition is positive acceleration. And let's see, is it speeding up or slowing down? Again, you might be tempted to think it's speeding up because it's going up. But remember, this right here, this is the smallest the speed can possibly be. This is stopped, right? 0 velocity or 0 speed is stopped. This is the smallest it can be. Here it's moving backwards very quickly, and here it's moving backwards the whole time. That's what this means, right? Anytime we're below the t-axis, negative velocities, this world of negative velocities, this means going backwards. Maybe I should write that down. This is going backwards, and this is going above the t-axis, means going forward. So in C, it's going backwards the whole time, but it's going backwards from faster to slower speeds and then stops. So in fact, it's slowing down. Okay. Then what happens in D? Well, in D, we can see that now it's going from 0 to positive velocity, so it's increasing velocity. Again, it has to be a positive acceleration. And now you can see it's speeding up. It's gone from stopped, 0, to moving, so it's speeding up. So you can this relationship here, where you can have decreasing velocity and speeding up, or increasing velocity and slowing down. These two in particular, B and C, these unusual cases, it might take you a little while to really kind of wrap your mind around how velocity, acceleration, and speed are related. Sometimes you have to let this sit and let it marinate in your brains for a little while before it makes sense. But I encourage you to think about it. It has everything to do with the fact that velocity is negative and speed is not. And remember, below the t-axis, negative velocities means you're going in the negative direction, which means going backwards. If you're in the positive quadrant, that means that you're moving in the positive direction, or moving forward. That might be a helpful way to think about it. One last thing I want to say about these graphs before we're done with this little module. Well, negative accelerations were A and B. And note that the slope of the line is negative in A and B. Well, C and D, positive accelerations, and the slope of the line is positive. Well, the slope on a on a velocity time graph, the slope of the graph equals the acceleration. It's an important relationship. Equals the acceleration. So here, the slope was negative, the acceleration is negative. Here we have a positive slope. That means that there's a positive acceleration. We can kind of prove that by remembering that the slope is the rise over the run, delta y over delta x. Delta y in this case is the change in velocity. Delta x is change in time. That's our definition of acceleration. So that's sort of the quick proof of that. All right, a lot to think about there. We'll practice this in class, and I'll see you next time.